Every semester I have a few holdouts that just do not want to use unitary analysis. The biggest problem there is they've started out with a really easy problem at the beginning of the semester. And they said, I don't need to go through this extra hassle of writing down units. I can just mash things into the calculator. And they get the right answer for the first week or so. And they're convinced that they don't need the more advanced problem-solving approaches. However, I've got here an example of one of the equations that we're going to be seeing later in the semester. Now, the reason I've got it there is I'm hoping to convince people to buy in and use unitary analysis from the very beginning of the semester. It will save you some serious headache. It will help you get your answers correct. It keeps you organized, and it can even save you from a bunch of hairy memorization. Now, let's take a look at why this can help you so much. Yeah, it's great in the small questions, but in the big ones like this, it really, really helps. So suppose that we were to set up the units for this. This is actually something related to the ideal gas law. It's pressure equals the number of moles of gas, a constant, the temperature, and then a bunch of other things that also include volume and some correction factors. Now, let's take a look what happens when I stick in all the units for that. This is what happens when we stick in the units for that. You can see that things are really nasty, and you can pretty easily imagine that if you were starting to stick in individual numbers along with these units, it'd be pretty easy to screw something up when you're sticking things in the calculator. However, if you're laying it out on the paper first, you can go through to make sure that everything is laid out correctly. And here's how that works. Remember, we can cross-cancel any units where they appear both in the top and bottom of factors that are being multiplied if there's fractions. Now, we see lots of examples of that. Let's go ahead and cross a few of them out. We can get rid of these moles squared here. We can get rid of liters squared here because it's on the top and the bottom of the fraction. We can get rid of moles over there. We can get rid of degrees, sorry, not degrees Kelvin, Kelvin, right there. Now, on the top of this fraction, for the first half of the term, right over here, you can see that all we have left here is liters, atmospheres. Over in this section, we've destroyed everything except for atmospheres. Let's keep going. We can cross-cancel these moles. Now on the bottom, all we have is liters minus liters. This entire chunk here is going to be liters. This is now in liters and atmospheres. We can go ahead and cross-cancel those liters. Check it out. All we have left are atmospheres. What do we have over here? Atmospheres and nothing else. Atmospheres minus atmospheres is going to give me only units of atmospheres, which is exactly what we expect for some sort of a pressure unit. Even with something this nasty, as long as we actually are rigorous and write things down, we can save ourselves a lot of headache. Now, even then, I know a lot of you are going to hold off from doing it, but let me put it this way. I've got a PhD in the field, and I still write my units down even in a really basic problem, because it has saved me from so many headaches in my lifetime. So please, learn from my pain. This is like when somebody tells you, really, wear sunblock when you go to the beach. Believe them. Their back hurt for 4 or 5 days, and they learned an important lesson. Learn from my sunburn. Use the units. Use the unitary analysis. It will save you from